because the moment you accelerate, the spring is natural, will be at natural length. Then the pseudo force will make the block B to move towards left. Then the block A will oppose, so there'll be some friction. I'll bring it. Take this yellow, lemon yellow. And similarly, a friction will be here. And spring force is what will show it. All these are the forces that are acting. Then no slipping occur means what is the basic necessity condition here? No slipping should occur. So he's asking the minimum value of mu for which there is no relative slipping between A, B. Who will accelerate? Who will in the trolley frame? There's a condition. In the trolley frame, in the ground frame, who will move the block B, who will move the block A? First of all, is it my diagrams are correct or wrong? Intentionally, I'm just putting in either way so that you should analyze. I think here it's like a two blocks. You treat this is one end of the spring, this one. So first what will happen? This will not move. First, this end will move. So if you start working in the ground frame, things will be a little bit easier for you rather than directly jumping to the trolley frame. So first what will happen as you start moving, this end you are accelerating it. No? Then this will get elongated. Then spring force will act. This spring force will accelerate the block B. The block A will oppose. So therefore the friction force on the block B will come like that. The friction force on the block A will act here. Then for no slipping, there should be a static friction. There's a one basic necessity idea. Okay, and both must have same acceleration. There should not be any relative. So this one. And now at maximum elongation, we'll go for it. Or some elongation X will take it. The work done by spring force and work done by friction should be equal and opposite in the ground frame. Okay, I think this will only accelerate the blocks here. No? In the trolley frame, what you're going to put it? You're going to just add that pseudo force. Pseudo force on what? On block B or block A? On both. We have two blocks here. The total pseudo force you have to show it. So in the trolley frame, you treat this as AB. Together, this has mass 2m. 2ma0 and kx. It's like this. So therefore, this pseudo force now, the work done by spring force. So now this velocity of this will keep on increase. Then at maximum elongation, the work done, this will come to from rest to rest, it has moved. So net work done by the pseudo force and the spring force should be equal and opposite in the trolley frame. So therefore, I'll write the equation. Initial contingent is 0 plus the work done by pseudo force 2ma0 into x. The spring force does negative work in the trolley frame. So kx square by 2 equals 0. So what is x equal to now? Kx equal to 4ma0. This is something very fundamental equation. So what we did all this analysis, trolley frame. In the ground frame, who will accelerate the blocks? Because the friction force will be equal and opposite in the ground frame. The whole system, what you see is like 2m. You just see that spring force is acting and it is making it to accelerate a0. So in the ground frame, what is the equation you're going to write? The spring force kx will, in fact, will accelerate this one. So, but what is acceleration? Can you write a0? No, it is some acceleration. Let it be. What is this frame now? What is a? You should write acceleration. in ground frame. So therefore, what is this acceleration? Kx by 2m. What is the value of kx? What is the value of kx equal to 4ma naught? 4ma naught by 2m. So this is 2a naught. This is at, in fact, if I write, instead of writing kx no, if I write it kxm, it will be better. And it will be more meaningful. Now, what about the option one? I think maximum, okay, now we'll go for the question one. Who will accelerate the block A? The friction only. F equal to me. What is m? What is A equal to? 2a naught. The minimum value of mu for this one. So what is the value of like for F to be static? So then what is the condition we can put it? So this will become mu mg equal to m 2a naught. So therefore mu equal to 2a naught by g. Question is very beautiful until the student has to break up this problem. Describe the motion of the block A and B. Of course, there is no slipping between block A and B. So what is the thing in all the discussion? There is no slipping between blocks A and B. There's a central idea, because the question itself is asked keeping this in mind. You check that also.
Sir,
okay. Yeah.
Sir, why they will have zero velocity at extended is maximum, sir?
You go for SHM at extreme point. What is the state of the block? Will be a test, no? That's what I brought here. Okay.
Okay, sir.
These are our answers. I'll write one more step. So therefore, I think it's very important the way you start the problem. So I think that's what happens in advanced exam. We know so many springs, blocks, so small idea. So usually we do have problems where without block B and we are done. So I just, when I bring one other block, no, things will change a little bit.